Good morning, everyone. Welcome to our science class. Before we begin, let's do a quick attendance check. Please say here if you are with us today. Gia,
Here.
Bunga, Ridwan,
Here.
Salama. Thank you. I'm glad to see so many of you here and I'm ready to learn. Today, we are going to dive into the fascinating world of waves and sound. These topics are not only important in science, but they also help us understand many things we experience every day. So make sure you pay attention, take notes, and get ready to participate. Let's start with something simple. Have you ever noticed the ripples that form when you throw a stone into a pond? Or have you ever felt the vibrations from a speaker when you play music loudly? These are all examples of waves. A wave is disturbance that transfer energy from one place to another without moving the material itself over long distances. For example, when you see ripples in water, the water itself doesn't travel across the pond, the energy moves through the water, creating the wave pattern. Waves are everywhere around us. They allow us to hear, see, communicate, and even feel. In these lessons, we'll learn about the different types of waves, their properties, and how sound works as a wave.
We have already known what is wave are. So now let's talk about the types of wave. There are two categories of wave. The first one is electromagnetic wave and second one is mechanical wave. Electromagnetic wave is a wave that do not need a medium and can travel through the empty space, such like a light wave, then X-ray and radio wave. Other ways, mechanical wave is the wave that need a medium and can travel through the air, water, and seismic. Like an example is like thermal wave or water wave and seismic wave. And then, but in mechanical wave, it can be divided into two types. The first one is transverse wave. Transverse wave is the wave that the particle move up and down perpendicular to the direction of the wave. For an example, when you move a rope like this, the wave will be moved forward, but the rope will be moved up and down, up and down, up and down. Or for another example, just like this. You can see the picture. It's a picture of the water, wave of water. And you can see the move of the water is up and down, up and down. So there was a transverse wave. Or we can illustrate it like this when the line in the middle is the direction of the wave and the particle will be moved up and down. And the second one of the mechanical wave is longitudinal wave. Longitudinal wave is the particle move back and forth parallel to the direction of the wave. For an example, it's just like when you talk to someone, your voice will be vibrate, and the vibrate will push the air particle and will be create a wave to the travel to the air of the listener, just like this. Or we can illustrate the wave is like this. When the line is direction of the wave and the particle will be moved with this like a string that will be moved back forward, back forward like that, and with parallel to the direction of the wave, not this. There's transverse.
Okay guys, now let's get into the properties of waves. By understanding these properties helps us explain why waves behave the way they do. So the first is amplitude. Amplitude is the height of the wave from its middle point to the crest or trough. The larger the amplitude, the more energy the wave carries. For some case, higher amplitude means louder sound. And then the second is wavelength. Wavelength is the distance between two consecutive crests or troughs. For sound, a shorter wavelength means a higher pitch. And the third is frequency. Frequency is the number of the wave that pass a point in 1 second, measured in hertz or Hz. Higher frequency means more waves per second. For sound, higher frequency means a higher pitch. And then the period. The period is the time it takes for one complete wave to pass a point. It is the inverse of frequency. And the last is wave speed. Wave speed is how fast the wave travels, calculating by multiplying frequency and wavelength. The speed depends on the medium. For example, the sound travels faster in water than in air, and even faster in solids. Okay, now let's try a quick calculation. If a wave has a frequency of 5 Hz and a wavelength of 2 meters, what is its speed? Okay, so the answer is to find the speed. Speed equals to frequency times wavelength. The frequency is 5 and wavelength is 2. So 5 times 2 is 10. So the speed of the wave is 10 meters per second. Yay!
Waves can do some interesting things when they interact with different materials or with each other. Let's look at a few key behaviors. Number 1 is reflection. When a wave hits a barrier, it bounces back. This is why you hear an echo when you shout in a canyon. Number 2 is refraction. When a wave passes from one medium to another, like air to water, it changes speed and direction. This is why a straw looks bent in a glass of water. Number 3 is diffraction. Waves can bend around obstacles or speed out after passing through a small opening. This is why you can hear someone calling you even if they are around a corner. Number 4 is interference. When two waves meet, they can add up to make a bigger wave, or constructive interference, and cancel each other out, or destructive interference. This is used in noise cancelling headphones.
So now move on to section 5 where we're gonna talk about sound waves. You must be wondering how can a sound be heard? It turns out that this is because sound is a propagating wave produced by a vibrating object as the source of the sound. So that sound waves are waves that propagate through a certain medium. Sound waves are mechanical waves that are classified as longitudinal waves. Why longitudinal waves? Because the direction of sound propagation is in one direction. And it's said to be a mechanical wave because sound requires a propagation medium. So, before reaching our ears, the sound from the sound source will first propagate in the air or water. There are 3 conditions for a sound to be heard, namely the presence of a sound source, a propagation medium, and a frequency between 20 Hz and 20,000 Hz. For example, you are talking to your friend. The sound source is you, and the propagation medium is air. That's why you won't be able to hear the sound if you are in an airtight place. This is because the speed of propagation of sound waves in solids is faster than in gas or air. There is a fun fact, where humans can hear sound from about 20 Hz to 20,000 Hz. Sound above 20,000 Hz are called ultrasonic, used by bats and dolphins, and below 20 Hz are infrasonic, used by elephants. Let's try a demonstration. If you clap your hand in a large empty hole, you will hear an echo. That's the reflection of sound waves bouncing off the walls. Now, to the section 6. We're talking the Doppler effect and real-life applications. Have you ever noticed how an ambulance siren sounds higher as it approaches and lower as it moves away? This happens because the motion of the sound source changes the frequency of the sound waves you hear. The Doppler effect is used in many technologies, such as radar guns to measure the speed of cars, medical imaging, ultrasound to observe blood flow, astronomy to study the movement of stars and galaxies. Waves and sound are also used in music and communication, phones, radios, speakers, and also animal communication, dolphins, whales, and elephants. And also noise-canceling headphones using destructive interference.